Okay, so last class, absolutely, we looked at the difference between the displacement time graph and the velocity time graph with the same number. So I have shared for you all this one. This is a very easy method to understand both the graph, right? This is the displacement time graph and it is here as velocity, and if it's a displacement time graph, they will not ask any time this acceleration because the gradient of the displacement time graph would be the velocity, right? So if they ask velocity is v equal y over x, this means this axis over y axis over x axis. So if it's a y, it's a 40. Then if it's a 4, then 40 over 4, it would be 10 ms minus 1. But here, look at this one. In this graph, the same number. But they will ask the constant acceleration, this point. So 40 over 4, and here 10 ms minus 2, this would be acceleration, right? At the same time, here if you look at this one, the constant velocity in 8 to 10 seconds, if you look at this graph, right, this is displacement time graph. Here, if you look at this graph, here there are two different directions can be found. That this direction from, if the graph is moved above the time axis, and this is one direction, and this is rest. I was talking about this rest. And here, if it comes towards the time axis, and that is opposite direction. Look at this one. That's why here, look at this one. If this is one direction, and this is another direction, opposite direction, right? So, uh, to find these the velocity between these 8 to 10 seconds, you should divide y-axis over x-axis. So I have divided 40 over this gap is 2, 10 minus 8, 2, then 20 ms minus 1. But here in this graph, look at this one, this is the graph, this velocity time graph, and it would be the same direction because the time axis, if you look at this one, if the graph in velocity time graph between, if you look at this one, the time axis, if it goes to below the time axis, and that would be the opposite direction. So if it's a time axis above the time axis, here in velocity time graph, that would be the same direction. But here this is one direction and this is opposite direction. Look at this one. That is the things that you have to know very much carefully when you do this calculation in the linear motion. So here constant axle deceleration has been found, and here if you this one, this is the constant acceleration, this is constant deceleration. You have to know every graphs which is given or which I have given, or sometimes you may have studied that one, right? The constant deceleration is equal, acceleration is equal y over axis. If it's a 40 over 10 minus 8, 240 over 220 plus minus 2, and here 20 ms minus 1, because displacement time graph would be always giving the velocity, and the velocity time graph would be always giving the acceleration. And if you look at this one, the third one is the total displacement is given, and here I have given a 0. If you want to find this for total displacement, you take this graph from guide your pen here, moving and the pen, and if it's finished here, don't put here 10 here. You just come to this one, this axis, y-axis. Now this is the point is 0, so it should be the 0 displacement. But here, to find the distance or displacement, here you should find a graph area. So you can find a separate one, triangular, then this rectangular, then this triangular, then you can find, you can add it, add all the things. So if they ask, what is the displacement with constant acceleration, you have to find this area only. What's the displacement with only constant velocity, you have to find this area only. And if they ask what is the displacement with constant deceleration, you have to find this area only. The very important things, this is moving in the same direction. And if you found this one total and the area of the trapezoid, you have into 10 into 4, 10 plus 4. If it's a 10 altogether, 10, and this gap is, the gap is 4, and the perpendicular height is 40, so the answer would be, and its wrong answer, it would be 280, right? 280. And so if it should be 280. Right. And now if you look at this one, the total distance here in displacement time graph, how can you ask the displacement time graph distance? You will think about something like that. Look at this one, the distance, because you know it's moving 120 meter, then come back 120 meter. So sorry, it moving for 40 meter and come back 40 meter. Altogether, it should be what, 80 meters. So I have put a wrong answer here because you should find that answer, and the answer would be 80 meter, right? So why I have put here 0, because when it press rest here 0 and you add this 40, then come back, it's come back this 40, the altogether total displacement would be 0 and total distance would be 80 meter. So this is the difference between the displacement time graph and the velocity time graph. Lots of people making mistake, you will confuse, so that's very important. If you take it this one very clearly, it has been given using some real great examples, right? Can you hear me?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Okay, thank you. So now I'm going to move this one, the question types now, right? Look at that. Third type question. So I don't have enough space to screen share this one, so I'm stopping. I am just reducing this size, and then I can have this side area, right, to do this question in one picture. Look this picture, and I'm bolding here, then you can easily read it. Okay, now. An object moved 100 meters with constant speed for 5 seconds, right? An object is moving, read the question very much carefully. The physics I was talking about, when you're talking about the physics, it's half of this one, not the half, even the 70 percentage. It's all about reading and understanding what is given and what they have asked. That is very important. So it's all about reading. So if you can't read well and you can't understand well, then you can't do this question. So an object is moving 100 meter with constant speed. So I am drawing here, an object is moving 100 meter. So it's 100 meter now. And when it's 100 meter, the time taken for that one is 5 seconds. So if you are very much tough to do this kind of question, you just write everything which is answer sheet. Answer sheet, you take this one, everything that I have drawn now. 100 meter. You're right, no problem. Time 5 seconds. Then what type of motion? Constant speed. So constant speed here. For 5 seconds, then speed, not velocity. Then it stayed at rest for 2 seconds. And the 2 second, again another 2 second, and that is rest. And then it travels in same direction. It moves same direction. Another 50 meter. Sorry, wait. Another 50 meter. 4. So another 50 meters. So if it's a 50 meter, then the time taken for that one, that is 2 seconds. So this is the question, simple question they have asked. The first question says, it is related to distance related question. Draw speed versus time graph. They will have asked speed versus time graph, not speed. I should ask what? I'm really sorry. Distance versus time graph. They have been asked to draw the distance versus time graph. So when you draw the distance versus time graph, you just draw here. I will draw very much small because I can't have this space here, right? Then I put here distance. So instead of distance here dt I use, here time I use. An object move 100 meter with constant speed. So you mark it this one. When you put this distance, you should give this meter here. Because in this question, they have given in meter, the time should be given in a second. Then you add this 100 meter. In how much second? 5 seconds. So here it would be 5. So then, how it is moving? Look now. It's moving in a constant speed. When it is moving in a constant speed, look very much carefully. When it is moving in a constant speed, you should know the constant speed graph should be something like this in the MyShapeThumb. So, if it's a constant speed, so you just bring this graph something like this. Then, again 2 seconds, it's rest. So, you take another 2 seconds and that should be rest. So, if it's a 2 second and 5 plus 2 second, 5 plus 2 should be what? 7 second. So, here in this graph, you should mention 7 here. You should mention 7 here. I have to change this one because I don't have time, sorry, space. So I'm taking here 100, then easy. Okay, I'm taking now here, okay, this graph would be something like this, okay. Then 2 second, it's rest. So it would be something like this. This is the rest graph. In distance time graph, this would be the rest. In velocity time graph, this cannot be this. In velocity time graph, what would be the graph? This gap. Can someone say please? In velocity time graph, if it's a velocity and if it's a time, what would be this gap? Can you say?
Constant velocity.
Constant velocity. Very good. But here this is rest now. This is distance time graph. Then it's moving 50, another 50 meter. Look, it is given a same direction. Same direction means it will be moved away from time axis. Time axis வெளியில நோக்கி போகும். நோக்கி வராது இங்க. So it will move something like that. How much of second? 2 seconds. So I put here 2 seconds. Again another 2 seconds. So 7 plus 2, 9. Then I can draw that one. So how much meter it is moving? 50 meters. So 100 plus 50, 150. Then I can draw the graph. How it is moving? It is not given in a moving. It travels same velocity, same direction. It traveled. I should give with constant speed. There is a mistake. In same direction, for another 50 meter for 20 seconds. So if it's moving in a constant speed, right? If it's moving in a constant speed, then I can draw something like this. Then now here, look very clearly. This is constant speed. This is also constant speed. And why I have drawn this graph away from this time axis? Because it's moving in the same direction. It's tough to teach this one in screen sharing, right? Seriously tough, but no problem. So this is the graph. They will give 2 or 3 marks. Second question, question number 1. Draw distance versus time graph. Yes, that's what's done. The second one, from the graph, find the constant speed for 5 seconds. How to find the constant speed now? The question number 2. Constant speed is equal. You can find how. Y-axis, you take this triangle over x-axis. Y-axis how much? 100 over 5. How much now? 20. This x-axis is 5. And if it's 0, then 5 minus 0, 5. And 100 minus 0, 100. 100 over 5, 20. ms minus 1. The third question. Calculate the speed in last 2 seconds. They're asking the speed in 2 seconds, last 2 seconds. You just come to this gradient now. This y-axis or x-axis. Lots of people will take this 150. Very wrong. Lots of people will take this 150. That's wrong. What you have to give on this one, this gap, y-axis, this gap. And then this gap would be, this is 150, this is 100. This gap is 100. So if it would be how much now? 50. And this gap now, 9 minus 2, what's that? 2. So I can find now speed is equal y over x is x. Y is how much? Look now. 50 over x 2. What's the answer now? 25 ms minus 1. If you come to this fourth question, find the total distance. If you want to find this one, it is moving in the same direction. Look at this. The distance, which means what? The total distance means what? The total length of an object is traveled. It is traveled 100, another 50. Then the answer would be, for fourth answer would be, how much? 150 meter. And next one, they have asked one total displacement. You know, it is moving same direction. Look, this one, it is moving 100 meter. Again, another 50 meter. So it is starting point. It is ending point. The total distance between starting point and ending point is called displacement. And also it is moving in the same direction. So when these two are, when it's moving in the same direction, distance and displacement would be equal. So the fifth question answer, displacement would be That's also 150. Do you understand this one now? Anybody have any doubt? We'll do different types of question, but please understand the basic idea. Anybody have any doubt? You can ask now. Okay, I hope you people got the answer. Did I send this one? I didn't know. Can you tell?
No, sir.
Oh no, so I'll send it then.
No, sir.
So you just take the screenshot or you take a snap from mobile, then you can easily take a screenshot, then you will get that one, right? But I'll send it to you. So what I'm saying this one, the basic idea, this is the one, this question which is related to speed and distance. In that graph, they have asked displacement too, no problem. Here it is moving constant speed, here also constant speed, and also 2 second is rest. Here rest. Rest in the graph account by inga adila. Don't, because it moved and rest. Please understand the basic idea. I hope you people got the answer, and I'm going to erase this one. Okay, come to next one, the type number 4 question. So please try to come to class, right? Please don't ask always these videos and blah 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 because you know the attending the class is like a not respecting, it's responding. How you are connecting, right? Okay. Let's move to type number 4 question now. This question which is related, it is given data. They have given a data and they're asking to draw the graph. See here, time axis 0, time, the distance which is given, that is also 0. When time is 4, the distance is 8. When time is 8, which means another 4 second, the distance is 16. When another 12 for 4 second goes and the time, the distance remains same, then another 12 4 second, it has changed into 12 into 4 16 second, and it has been changed into 16 into 32. It's very simple question. An object motions, distance and time is given. Draw the distance time graph. Can you draw? You can, but I'll draw that. So when you draw this graph, you don't need to put these graph points and everything. That is old method. So look how I'm drawing. I'm drawing here and we'll do the question here, right? I'm drawing here. And from this one, here the velocity, sorry, I used to do this velocity. This is distance and this is what? Time. And here second and here meter. And this point is 0. When time 4, the distance is 8. So I take 8 here. Then 16 here. So it would be 16. This would be 8. Another maximum distance would be 32 here. And when time is 8, when time gives 8, when distance is 8, then this would be 4 seconds. When distance is 16, the time would be 8 seconds now. And when time is 12, distance also 12. So I can show here the points. This is one point. This is another point. And this is another point. And when time is 16, this is 32. You bring it here. No. And it's 16 now. And the point would be here, this point. And if I draw this now, something like this you can and here, and I'll go this one, something. This is the graph. Do you understand that? So very easy one. You just take these data and draw the graph. And the second question says, from the graph, find the speed of following times intervals. From 0 to 8 seconds, find the speed. Speed can be found, see, y over x. Here speed is equal, y is this point, this gap is 16 here meter, and the time would be 8. 16 over 8, how much? Second. 2 ms minus 1. Second one, 8 to 12. If you look at this one, 8 to 12. This is constant speed. Am I right? Am I right? Constant speed. How about this one? Tell. How about this one? This motion. Comment about this motion. This gap motion.
Rest.
What's that?
Rest.
Is that rest?
It remains rest.
It remains rest, because I was talking that one last question also. And this is also constant speed. But it is the same direction. If it's moved, come back here, then that would be definitely displacement time graph. That would be definitely displacement time graph. So then here, if you come to this 8 to 12, if it's a rest, what is the speed? If it's a rest, what is the speed? What's that? 0. If it's a rest, it would be 0. And third one, 12 to 16. Can you find this 12 to 16? This is the one, this gap. Right? I'm erasing this one, then you will confuse. This gap. Find and tell me. This is 32. And here you come this one, this is
4 ms minus 1.
yeah, right. This is 16. Okay, here also 16. This is also 16. And this gap is 16 minus 12, 4. So x is, and this 32 minus 16 is 16. So speed is equal y over x. Y how much? This gap is 16. And this gap is 4. 14, 16 over 4. 4 ms minus 1. Does that make sense? Any doubt? Are you all okay? Right. So I'm moving to next question now. So it's all about what? ஒன்று நல்ல விலை கொள்ளுங்க நான் தமிழ்ல சொல்றேன் டிஸ்கிரிப்ஷன் தந்து கிராஃப் கேட்பாங்க இதை தந்து கிராஃபுக்கு கேள்வி கேட்பாங்க or else நம்ம distance time graph we'll be talking about that or velocity time graph and that types ಇನ್ನೊಂದು graph director தந்து question கேட்பாங்க. There are 3 methods. Now let's move to next one, the type 6. The type 6 which is related to displacement time graph. So we have finished distance time connection question. It is not even in your book. Sometime in your some of the examination it is being asked, and also if you see the guide, sometimes they asked to give. So that's what I have talked about this one. Look now, the question number 5, the type 5, an object travels in a straight line in a constant velocity. An object travels in a straight line, travels 40 meters in a straight line in a constant velocity for 5 seconds. The question asks velocity here. So the 40 meter here, it is now should be taken as what? Can you say? It should be taken as displacement. So displacement is given, that is 400 meter. And the time is given for 5 seconds, so 5 seconds. We looked at velocity is equal change of displacement over time. So I put small displacement over time instead of displacement. You write simply, that's very easy. Writing simple, it's tough. You write, okay, displacement. If you forget the symbol போட்டு படிப்பிடிச்சு தான் இந்த history சமூக கல்வி social study மாதிரியான science. You write velocity is equal displacement over time, no problem. What is the displacement? 400 meter. And a constant velocity, the time 5 seconds. 400 over 5, how much? 80 ms minus 1. Here, speed and velocities of what's that? The unit would be same. This is which is related to displacement related time question. Right? So this link will expire by 1 minute. So we'll go to another link. So I'm stopping and connect from next link.